Okay, we'll go ahead and get started. My name is Maher. Can you guys hear me well? Through chat or through microphones, please.
Yeah, I can hear you.
Thank you. Let me go ahead and share my screen. Were any of you guys with me last week for the lesson? Or is this your first one? Yeah, so we'll go ahead and talk about what will be on the test real fast. 2 FRQs. You have 45 minutes to take care of them. 25 minutes for the first one, worth slightly more than half your grade. 15 minutes for the second, worth only 45%. The units that will be on the exam: 1 variable data, 2 variable, how to collect it properly, making sure everything is valid and repeatable and all that stuff. Probability and random variables, a few calculations here. Sampling distributions, this is where it usually gets a little tricky because we're going to have to determine how we could approximate a lot of things to normal and then use a Z or T table to get probabilities that we need. And then those probabilities are going to help us make inferences later on to reject a null hypothesis or to fail to reject it and so on. We're not going to have anything for chi-squares or inferences for slopes. That means no hypothesis testing for slopes, but in 2 variable data, there's still correlation, still a bunch of stuff here from right there. So I wanted to ask if you guys joined me last week because I have FRQs from 2019. And I'd like you guys to work on these if you haven't seen them before. So have you seen this FRQ right here?
I've never seen that.
Okay. So let's go ahead and give this one a shot. So I got quite a few listed out, some good ones, and I think we'll start with this guy right here. So the sizes in square feet of the 20 rooms in the student residence hall at a Syrian university are summarized in the following histogram. Based on the histogram, write a few sentences describing the distribution of room size in the residence hall. So I kind of want to, I know we're getting extremely close to the test. I think it's 1 week from today. So I wanted to kind of give you guys a moment if you needed to take any look at any notes you might have. But I wanted you guys to type up your answers as well as you could so I could kind of grade you, see if you know how much to answer, if you know where the points are going to lie. And if you didn't, we'll explain what you want to throw in there. So I do want you guys to, well, if you can, for some of the easy ones, you could just, speak out loud. But for the harder ones, I kind of want you to write it out, explain what's going on. So, but for here, take a minute, and if you can, type it in or explain it to me when you have an idea. How might you get the points for the distribution? So one thing I like to ask you guys to think about is what 3 things do they always ask about for any distribution? They're looking for shape, center, and spread. Okay. What can you guys tell me about the shape?
I would say it's bimodal.
Bimodal, definitely. What else can you say about it?
It's somewhat symmetric.
Perfect. What about the spread?
So is spread just like what it ranges from, like 100 to 350?
That's a good way to explain it. Yeah.
So I would say it ranges from 100 square feet to 350 square feet.
Mm-hmm. So far you hit 3 out of 4. This is one thing that often it's not given in every single distribution, but if there are, you want to mention potential outliers.
Hmm.
But doesn't seem like we have any here. It's all nice and symmetric, all jumbled together. Nothing
Yeah,
far.
so no outliers, something.
Yes, exactly. So shape is about symmetrical. Perfect. So that's good. But definitely bimodal. They needed to see that for one of the points. What are some reasonings something might have a bimodal distribution? Do you guys kind of remember what could create a bimodal distribution?
You could have like two different groups.
Exactly. So like for human heights, we have a bimodal distribution because there's an average male height with a lot of males there and an average female height. So we have a bimodal height distribution for the population of humans as a whole, but then that's because of the two different groups in there that have their own means, and that's why we would see that bimodal. So that's a great answer there. Let's go. I think we're ready for B. Summary statistics for the sizes are given in the following table. 5-number summary and mean and standard deviation. Determine whether there are potential outliers and use the following grid to sketch a box plot of room size. How do we do box plots?
So it would start at the minimum, and then go to Q1 where the box starts, and then the middle of the box would be the median, and then it goes to Q3 and then max, right?
Exactly. So we got something like that, and then Q1, about 174. All right. Then we got the median way over here, Q3, max, and this is exactly lines, and then these are the full box. All right, any questions with the box plot? They like to ask box plots for sure. I could definitely see them bringing one there. Stuart, any questions with that one?
Nothing right now.
Gotcha. So what characteristic of the shape of the distribution of room size is apparent from the histogram, but not the box plot?
I think the bimodal part.
The bimodal part, absolutely. Oh wait, we also forgot one part here, the determination. We can't really determine from here if there, I mean, we can see if we think there are outliers here, but if it asks us to determine if there are potential outliers, we have a specific process. You guys remember what we have to do there?
Isn't it like Q1 minus 1.5 times IQR and then Q3 plus 1.5 times IQR?
Exactly. So if we get something less than this or greater than this, we got outliers. So what is the IQR here?
100 like 18, I think, something.
Exactly. 292 minus 174, 118. So Q1, 134 minus 1.5 times 118. Yeah, that's pretty negative. So definitely no outliers, but they kind of wanted you to give them the cutoffs and for sure determine there are none.
Mm-hmm.
If they ever ask for that. So that might have been a point I might have forgot about if I didn't really read it carefully. So we have to pay attention to the wording. A lot of the times they might just say list something, or do you think there might be one? But if they're going to tell us a word such as that, we're going to have to go ahead and do the calculation. But then for problem 1, any questions on any other part here?
So for the histogram, when you talk about center, what would you say for that? Do you have to talk about mean and median, or like what?
You don't have to, because when you say center, bimodal means it has 2 centers, and that is the description of it.
Okay.
You might say there's we see a mode maybe around 150 to 200 and another one 250 to 300. That's something that might be important there. They give you the points without it, but most of the responses that I have seen did add that in there. So, but yeah, good question. Okay, I think we're ready for question 2. So I'll let you guys read this to yourselves, and then when you're ready for A, let me know. Whenever you have treatments, you can go ahead and let me know.
So would treatments be the mixture, the mixtures?
Yes, the 4 different concentrations. What are the experimental units?
Would that be the insects?
No, this one was a tricky one.
So would the experimental units just be the different fungus groups they're spraying it on?
Different groups there's.
Because it says effective of using fungus to control different insects, of using a fungus. So would the fungus be the experimental units?
The fungus, because we are changing the concentrations of the fungus mixtures, those are the treatments, or basically the levels of the independent variable. So that would be treatments. Experimental units are basically the subject that you are taking a data point for. Are you taking data on insects?
So is the number of insects alive then?
That's what we are measuring. That actually becomes a response variable. But what are we measuring for? What are we measuring for in the number of insects alive? It's a little. So what's the subject of our study?
The actually I don't even know, honestly.
Yeah, this one really tricky. This one's actually the individual containers. So you have the 20 individual containers, and each container is measured for how many insects are still alive inside of it. So the containers are what's getting measured for a specific variable. Does that make sense for the experimental units? usually it's pretty obvious. They have a person taking a placebo or a medicine. They're the experimental unit. You're measuring that person's heart rate change or something. But here, they kind of had a subject which had subjects in it. So they really tried making this one confusing. But as long as we know that experimental unit is the subject that we are measuring a specific variable for, then we are measuring the containers for the response variable number of insects alive. So questions with that one? I know that's a really tricky one.
Okay. A little confusing.
Yeah, but I think that subjects one, if you could phrase it like that, you'd definitely be able to jump through that hoop that they're trying. And again, this was probably the most confusing way that they could have asked for an experimental unit, so they really knew what they were doing with this question.
Mm-hmm.
But let's move on if you guys feel good. Does the experiment have a control group, and explain? So not good enough, say yes or no and give me at least a sentence. Why?
I would say yes, because they have a group that they say they sprayed a mixture of 0 milliliters per liter, which would infer that that group is receiving 0 treatment whatsoever. So I would consider that to be a control group.
Perfect, because that makes a great comparison between everything else. Excellent. So that would count full credit. Describe how the treatments can be randomly assigned to the experimental units so that each treatment has the same number of units. So anytime they ask for random assignment, you could do a few different things. Easiest thing to say is basically a random number generator.
I have a question.
Yes.
One of the easy ones that we used in my class for the remainder of the year was just the numbers in a hat,
Yes.
listing pieces of paper 1 to 4 in this case, and then just having each group, or I guess in this section, each of the 5, because there's 4 numbers and 20 individual containers, so each container, I guess, will have, it'll be 5 of each mixture.
Mm-hmm.
So basically just have a number drawn 1 to 4 and then put that with each container, and then so there should be 5 of each mixture. So in this case, there'll be 5 control groups.
Okay, so pretty close. But how many things do you have in the hat that you're talking about? How many slips?
5 of each number, if each number 1 to 4.
Got it yet? Then if you explain it like that with 20 slips, that's in the second, probably the other alternate easy way. Yes, I'd say so. So as long as you did explain 5 and of each, 100%, because that way you could make sure, and then you have to probably say without replacement or suggest it in some way. And other than that, perfect there. So any questions? So I know the random number generator is a little bit more like computerized. So if you can spit this one out whenever they ask for it, that'd be nice.
So would you just say by using a random number generator, do you need to, is there anything else you need to say?
Oh, you kind of have to basically do the random number generator and then give everything a label, and then 1 through 20, and then the first 5 that are picked are going to go. So you're going to do a random number generator of 1 through 20, and then the first 5 that are picked can go in the first group, and then the second 5 that are picked can go in the second group, as long as you make sure that if you got the same number again, you just skip it.
All right.
So you do have to explain quite a more difficult scenario. So if you can, the slips of paper, I'd say go with that one. I like that one a lot. Questions before we go on to the next one? Okay. here, a medical researcher surveyed a large group of men and women about whether they take medicine as prescribed. The responses are categorized as never, sometimes, or always. The relative frequency of each category is shown. One person from those surveyed will be selected at random. What is the probability that the person selected will be someone whose response is never and who is a woman? Take your time. Let me know when you guys have an answer.
Would it be 0.0636 divided by 1?
Yes, perfect.
Wait, why would it be divided by 1? Wouldn't it be 0.53? Or is it?
Because it's from all of those selected, all of those surveyed. So that would be, what is the probability that so if you did that over 0.53, you're saying given that they're a woman, what's the probability of never? That's what you would have found right there.
That's what the third one is asking for. Yeah.
Exactly. Looks like.
Okay. All right.
Yes.
Oh, because it said given. All right.
Yeah. So we don't need to know that they are a woman for sure. So they could be either or. But if they are a woman and they're here, of all of the total. So usually I would have just said 0.0636, but I like how you said that over the total here, because let's say it wasn't a relative frequency and it was a frequency. That's how you would find the proportion, by that divided by the total. So it's very similar to if it were harder. So divided by 1, definitely important if it expands to regular frequency. What about 2? What is the probability that the person selected will be someone whose response is never or who is a woman?
So now would you add 0.12 plus the 0.53 out of 1?
If you add this, then this, notice we end up adding this plus this, but then we do this plus that.
Oh, yeah. So you're going to subtract that.
So would you just add the 2 and then subtract 0.0636?
Exactly. Or you could just add these 4 right here, alternatively. But yes, there is a formula. They'll give it to you like in the beginning of the test anyways. But you're going to have the probability of A or B equals the probability of A plus the probability of B minus the probability that A and B both occur together. So probability of never plus probability of woman minus the probability of woman who answered never will give us our final. Questions there? And are you guys familiar with the notation? Because in the test, you're going to see this. Let me show you. So no, can you guys still hear me well?
Yeah.
Okay. So right here, this is the union. And that's where they, they intersect, but we really don't really need to know that. But here, the A and B, so the intersect is where they intersect, A and B. And then the union is you add up the A's and then you add up the B's, but then you don't want to double count that one right there. So you're going to get these on your test. This U means or, the upside down is and then the givens are written probability of A. A vertical line means given B is true. Then you have to do the probability of A and B over the probability of B. So this is what they give you on your formula sheet. And then that's how we use it right here, except just or and and. Next, for the people surveyed, are the events of being a person whose response is never and being a woman independent? Justify your answer. Do you guys remember the approach you want to take here? In order for independence, the probability of A given B must be the probability of A anyways. B, if it were independent, B should have no effect on the probability of A. So, are you guys still with me there?
Yeah.
Now we have to calculate. What's the probability of never, so never and being a woman. So we could find the probability of basically never, given that they are a woman, and relate that to the probability of never. Alternatively, we could do the probability that they are a woman given that they said never, and that should be the same probability as being a woman. Now let's go ahead and try it. Probability of never given that they're a woman. So it's going to be the probability. So find that for me, guys. What would that first probability be? Probability never given a woman. So we kind of skipped over it because we knew he could do it. But what is it?
Is it 0.5864?
No, how'd you do that?
I just did, well, for if it was the third one, I just did 0.65, which was the addition of the two, minus 0.0636 in order to get rid of the repetition.
Oh, no, we're doing the given again. The repetition only occurs in the ors and ends.
Oh, okay.
Yeah, so with the given, notice the given doesn't have any of those.
So would it be 0.12?
Yes, because you end up doing, well, how'd you get that?
The 0.0636 divided by 0.53.
Exactly. So we did the probability of, never end woman, 0.0636, over the probability that they are basically a woman over 0.53. And that equals 0.12. So we just showed right here that the probability of never, given that they are a woman, equals 0.12. But what's the probability of never anyways?
Also 0.12.
Also 0.12. Therefore, we are sure that we proved independence. The other way which I did it, actually, well, since we calculated that, fine. But if we wrote probability of woman given never, so the probability of a woman given never is the probability of a woman and never over the probability of never. So that would come out to 0.0636 divided by 0.12. And notice we get 0.53. So the probability of woman given never is the probability of a woman. So either way we look at it, it's going to work out. So you don't have to worry about which way do I do it, as long as you write it correct, where you know A given B must equal A, not probability of B. That's like the only mistake I might see I could see somebody doing there. But if you really clearly label it out, you could solve it correctly from either approach. Any questions? Okay. C. Assume that in a large population, the probability that a person will always take medicine as prescribed is 0.54. If 5 people were selected at random from the population, what is the probability that at least 4 of the people selected will always take medicine as prescribed? Support your answer. Okay. Any ideas?
Could we do a binomial CDF here?
Can we?
Because we have trials, which would be 5. We have a probability value of 0.54 and an X value of 4. So could
we got a fixed number of trials, we got a fixed probability, and you have to label these if you do want to use the binomial. You have to explain, the requirements. Okay, so fixed number. What else did you have?
We also have a probability.
Probability, which is going to remain the same.
Yep, and then we have a X value of 4 because you're asking for at least.
That's not part of the requirements.
Oh,
here's a big one: 2 mutually exclusive outcomes.
Oh yeah, so it's it's either a yes or no question.
Mm-hmm. And then the last one is like, I see why it's its own fourth one, but it's kind of the same thing as the second one. The probability remains the same because subsequent trials are independent. Like the first person has no effect on if the second person did it, and it's 0.54 across for everybody. So it's kind of like almost the same requirement, but you have to phrase it because they do have slight differences in them. Does that make sense? But still 4. Fixed number, mutually exclusive, probability remains the same, kind of because the trials are independent. Now, what is the actual answer? So you said binomial CDF. I like that. That means you're good with your calculator.
Yeah, I got an answer of 0.954.
Let's see. I didn't do the calculations yet. Let me take a look. No, it doesn't look like that. So what did you do when you did it? You did a binomial CDF, but what did you plug in?
I plugged in, hold on. Binomial CDF trials 5, p-value of 0.54, X value of 4.
Okay, so real quick, James, are you familiar with the binomial CDF as well, that function on the calculator?
Yeah.
Okay. So do you know why what was wrong there?
Yeah, because isn't CDF from your X value and below?
So that would be the X
You want the
value
other way around, right?
below. Yes. So what you solved for was the probability that it's 4 or less.
So once you do trials, or no, not trials, X value of 3, and then that comes out as 0.75, and you do 1 minus that? Should be like
Yeah.
0.25.
Exactly, because CDF can only give you, I mean, depending if you have the newer calculators, it could do other stuff. But on my calculator, it can only give you that value or less. So if you want 4 or above, you have to subtract 3 and below. So 1 minus the binomial CDF, 5 with 3 and 0.54. Does that make sense?
Yeah.
Okay. Alternatively, you could have done 2 PDFs of 4 and 5. If you're really like nervous and forgot how it works real quick, do 2 PDFs. If you know it's just a couple things added together. And if I had extra time, I might do it both ways just to make sure I get the same answer and like confident I didn't mess up anything in my calculator. So, I mean, since you only are allowed to work on one question at a time and it's not a race, you only got 25 minutes, and after that you submit your answer, then question 2 is going to pop up. So you do have extra time if you can check your answers a couple different ways. That'd be helpful. But then yeah, 1 minus whatever you guys got. Perfect. A lot of people lose points because they don't explain the requirements and say, look, I'm allowed to use a binomial. And then or they might use it incorrectly, but you guys, together we handled that really well. So any last questions there? Okay. So this one's a little long. I'll let you guys read it to yourselves, and then we'll talk about it a little bit. See if you have any ideas where to go or questions. So go for it. Oh, one thing to mention, sorry. Do state I am using a binomial CDF and what you are plugging in. Since you are not doing the calculations, just write down really quickly binomial CDF with n this, x this, and that, 1 minus it, and then up the out, he knows exactly what he's talking about. I'll give you full credit. First thing I'm going to ask, what might the null hypothesis be?
That they're equal.
Sorry, lost connection for a second. Let's go back. Okay, so sorry about that. What was the null hypothesis again?
Would it be that they were equal?
Exactly. So we could say what's equal, by the way.
What is it? The resistance to the glyphosate or whatever.
What statistical what statistic are we going to use to analyze? So you're going to have hypothesis tests for only two different things, means and proportions. We're not doing the other ones, no chi-squared or whatever. So we wanted the proportions equal. Proportion of 2017 equals the proportion of 2014. What would our alternative hypothesis be?
That that P2 is greater than P1, or P17 is greater than P14.
Something like that, absolutely. Yes. So we have that. Now when that we wrote the null hypothesis, basically what type of test would you want to do here on this type of null?
I think a two-pronged Z test.
A two-pronged Z test. Perfect. Any questions as to why that we would pick that? Okay. And then how would we plug everything into the two-pronged Z test?
I did the I calculated like the 19% of 61, which was like 12. And then so I did that for my X1, and I said N1 was 61. And then I did 38.5% of 52, which is 20 out of 52. And then I said and then I did that it was less than P2, and then I got a p-value of 0.01.
Okay, that's wonderful. Now, you stated the null, you performed the test, and you identified it by name. Now, can you interpret it and give us the final sentence or two?
Yeah, so since it's less than 0.05, I would reject the null hypothesis and say that there was significant evidence that P17 was greater than P14.
Absolutely. So at least at that 0.01 level. Now, that would give us 4 out of 5. Now, there's one other thing that we needed to do. We needed to prove that we can do a two-pronged Z test. So what were the requirements for performing the first
It
one?
has to be random first, and we know that it's random because they stated that there was random selection of plants.
Uh-huh.
And then we also need to check for independence and normality. Independence would just be n times p, and
What about NP?
np, and then n times 1 minus p have to be greater than or equal to 10.
So they both have to be greater than or equal to 10.
And then we also need to check if the amount of, I guess, like items in in question here are greater than 30?
We don't need greater than 30 because all you need is NP greater than 10 and 1 minus P greater than 10. You need
That's
that successes and 10 failures. So minimum is 20, but that's only if it's a 50-50 chance.
Okay.
But then, and I'm not sure if they're using must be less than 5% of the entire population or 10% of the population. I forgot what that requirement is now.
Yeah.
But
It's 10%, I think.
yeah. Okay, then you say it's the sample size is for sure. I mean, we only got 61, less than 10% of all the cocaine plants in that area that we're talking about. So we know it's a huge population, so independence is good. And the approximate normality, so here's the independence, here's the normality of these two conditions above.
Okay.
So that was the only other thing we needed to state to get full credit that, hey, look, we are able to do a two-pronged Z test. And then, okay, fine, here it is, and here's my interpretation.
Perfect.
So, awesome. Nice job so far. Let's go to this one right here. So this is from 2018. If you've seen it, we can definitely skip it, but well, it's a little bit of binomial as well, so we might be able to do something else with the last bit of time we have.
Okay.
Let's go here. Go ahead, read that one, and let me know when you're ready for A.
Okay. So for A, it's talking about causation, which we can only conclude when we've randomly selected uh, like patients or subjects from a large population, I think, or is that generalization?
In order, you're on the right track, but you're missing one big thing.
Because I know it says that it said was conducted and they were randomly assigned.
The random assignment is necessary,
Yeah.
but random assignment in what type of research method? Because I could randomly assign for surveys. That doesn't show causality.
Be like a certain design.
And an experimental design
Okay.
for you to determine causality because you're only manipulating one independent variable
Mm-hmm.
as opposed to a correlational research or something else like that. So you're really close, but you really needed to say the word experiment to get that full credit there.
Is that to distinguish between experiment and like an observation?
That's the main difference, yes.
Okay.
So there's a few different types of observational studies. There's like longitudinal, where they might focus on a few people over a very long period of time.
Yeah.
There's a case study where you just study one person really, really well. There might be, so observational, I could come in and just check your heart rate every like 20 days. Or I could do a naturalistic observational study where I'm not even interacting with the subject. I'm trying to sit as back far away from them and take notes on what's going on in a naturalistic setting where they don't even interact with the researcher at all. So there's those. Then there's the retroactive study where they just look back at details. That doesn't really mean much. They look back at records. But the naturalistic observation, that's a tricky one because you might see like, oh, I might go out in the real world and do an experiment in nature. But if you're actually interacting with the participants, you're not doing a naturalistic study, even if you are in their environment. Does that make sense?
Yeah, that makes sense.
Okay. So those are the main big ones, but experiments, the only one that can prove causation. Correlations, I mean, they could just show correlations. That's all that the other ones can do. Show that things are relatable, but causation, experiments. So, yes. And if you're ready, go for B.
Okay. So for this, we would run a 2-sample Z test. Or wait.
Let me see.
Or no, I think it's actually the 2-sample t-test.
Why?
Because we're considering here the mean number of days, and I'm trying to remember the difference between why you would take a t-test. Because I've seen a question like this before. I could be wrong. It could be a z-test, but
It would be a Z-test if you knew the population standard deviations.
okay, in this case you don't.
However, when we're reading it, it seems like they don't know. Not only that, you have to know the population means. Yeah, well, whatever, we got these. But these seem like sample standard deviations.
But not the standard deviations of the population.
Exactly. So it seems like of these 210 patients, here's the sample size, the sample mean, the sample standard deviation. So, I mean, and we could usually assume that unless it's clear that they stated population. So
Yeah.
they're usually going to have to state it's clearly the population standard deviation. So because they didn't and it's in the table with a bunch of samples, for sure we're going to do a t-test.
Okay. Plug that in then.
Or a two-sample t-interval could also help you do it. Because remember, any time you do a hypothesis test, you get a two-tailed hypothesis test, a confidence interval could give you the same exact information. Does that make sense? Or do you want me to elaborate on that?
Can you elaborate on that a little bit?
Yeah. So let's say we have a two-sample t-test. We are testing, is the difference 0 or is the difference not 0? So
Okay.
in a confidence interval, let's say we get an interval. Let's say this is our interval, negative 3.5 to negative 2. Then that means we are 95% confident that the true value of the difference is between negative 3.5 and negative 2. Because 0 is not in our confidence interval,
Oh, okay.
we reject the null.
And
If
in
0 is not, we could not reject the null.
yeah.
Okay, so
And
go ahead and finish up, or let me know if you had questions.
yeah, for the t-test, when I'm putting it in, we want the new treatment to be less than the standard treatment, correct?
Let's see, do they have
Because everything is in days, and I'm assuming if you have less days of recovery time, that would be considered a more effective recovery.
Yes, that sounds good. That's the way I would interpret it. But what was our alternative hypothesis? Let's see if they clearly stated that.
Um, let's see.
I mean, yeah, if you want to test the effectiveness of the new procedure, you're pretty much doing a one-tailed test saying, does it go down? Absolutely. If it just said if it's testing if it's different, okay, we do two-tailed. But there, exactly.
Yeah, 'cause I think the question was like, will it have a less recovery time?
Mm-hmm.
So in this case, we got a t-value of 7.1, p-value of 8 point, a really small p-value. So the p-value here was significantly less than the alpha of 0.05, which we would have stated. Therefore, we reject the null hypothesis. Saying that they're the same. I would have said for the null that they're the same, so therefore we reject that, saying that they're not the same, and we would have evidence to support the alternative that the new procedure will result in a lower or a smaller recovery time than that of the standard.
That's perfect. Yeah, that's really good. Okay. Let's see. That's a pretty long one. Let's go back. What were some of the most important things? Well, anytime we do any sort of test or try to turn any distribution to approximate it into a normal or a t, we have to remember all our requirements. So make sure you have your requirements sheets listed, or you got some sticky notes in your textbook where every requirement is. That's going to be something pretty important. Now, experimental units, I remember that one's something that trips a lot of people up. What if they ask another word they like to ask sometimes? Operational definition.
What was the word again? Operational.
Operational definition.
Okay.
That's another big one. And that would be, so just to kind of get out of the way, the exact thing that's being measured. So here it would be uh, the number of insects. So pretty much in this case, it's the same thing as that response variable. So it'd be like, let's say you're doing a survey, it'd be, let's say you're trying to measure stress. Your operational definition, your variable is stress, but your operational definition, how do you measure stress? And then let's say you're doing it with a survey. Well, obviously there's a lot of validity problems with that because first of all, it's just people answering a couple questions. They might lie about their questions, or those questions might not really delve into how stressed they might feel. So your operational definition of stress might be wrong, which could cause validity problems. Um, or, basically, many different things, or just because it's a self-response bias might cause validity problems. So I know we didn't talk about validity today, but I definitely want to end on that because I think that's going to be something they're going to mention for sure. Like, why might a study not be good? You already kind of talked about generalizability. You brought that up earlier.
Mm-hmm.
If you're going to talk about it, make sure it's clear that you state because it's not because only this portion of the population was surveyed, you cannot generalize it to a broader population. Don't just say you can't generalize it. Make sure you can't, so make sure you kind of define everything a little bit better there. Well, I mean, I didn't see what you did there yet, but make sure you elaborate as much as you can on those types of questions.
Okay.
That, did you have any last questions for me today?
I don't think so.
All right,
Perfect.
perfect. Well, I know you have a week, so keep up the hard work. You seem pretty, good for having a full week to, continue your studying. But if you would like to, have any future lessons, I'm offering a discount for anyone who would like to work with me for AP Stats for next week of 70, and from down from 100 from normally. So if you would send me a message, and we'll definitely give you that discount. Other than
Perfect.
best of luck on it, and have a nice rest of your day.
Thank you. You too.